So most people jump straight into machine learning, but in real sports analytics, the model is the easy part and the data set is the real work. So welcome back to the NIIT YouTube channel, and I am building a cricket T20 win predictor step by step, and this is the episode 2, which is the mass state data set. So I'm going to show you how you can build a mass state data set before we move on to our further episodes. So quick status update. And this is exactly where we are right now. So I have already created the project folder structure. So I have my data raw, I have my data processed, and then inside output, I have output plots. And I have also created one Python file, that is episode 2, build matchstate.py, and the full backend code is inside it. Now the only thing that I have not done yet is send over my anti-gravity prompt. So in this episode, first I will walk you through the code like a beginner, and then we will run it to generate outputs. So what I'm going to do right now is send over this prompt to anti-gravity. So what exactly is this prompt? I will read it out for you. So my prompt is build episode 2 backend for cricket T20 win predictor. Use Python, pandas, numpy, matplotlib, and I have my input file as data raw ball by ball CSV. I have posted that over here, and I have my output as data process mass state balls.csv and data process mass state over.csv, and 4 plots in output and plots, and avoid deleting any files. Ask before any terminal command that modifies system state. So after I send over this prompt, the anti-gravity is going to revert me back with 2 more CSV files, that is my mass state ball.csv and mass state over.csv. So let's just see how it proceeds. So I'm going to send over this prompt now. Now we'll just wait for the output to generate. Now this script will create 3 things. You will have a mass state ball.csv. So these are the ball by ball mass state for chases. And then you have mass state over.csv, which are the end of the over mass states, and 4 sanity check plots saved inside output plots. So if you go over here, click this, you will see that we have 4 sanity check plots. So let's start from the top. So I have just opened up my Python file, which contains all the backend code inside it. Now at the top, I have imported these things. So I have imported OS to create the folder safely, and then I have imported numpy for fast numerical calculations. Then I have also imported pandas to load and transform the CSV into data frames. And then I have also imported matplotlib to generate and save graphs. Now I'll go down. So what is this? So this is the configuration section and basically the settings. So data path, it will tell the script where the raw CSV file lives, and we have our ball by ball CSV over here. And then we also define the 2 output files that we just generated. So we have our mass state ball.csv as outball, and we have mass state over.csv as outover, and both inside data processed. So after that, we also define the plots folder as output plots. Next, we set the cricket constant. So a T20 innings has 120 legal balls, right? And a team can lose up to 10 wickets. So I have described all of that here. And finally, the momentum window is set to 12, meaning calculate momentum using the last 12 legal balls. That's the last 2 overs worth of actual deliveries. Now after that, I'm going to go down to my default calls, which is very important part for your data set. So some CSVs come up with headers like match ID, innings ball, and so on. But in our case, if the CSV has no header row, we still need column names so pandas can refer to them. So this script defines a default schema with 22 columns, that matches the structure of a ball by ball file. That's why you see names like match ID, innings, ball, runs off bat, extras, and then wicket columns like wicket type and player dismissed. So for your reference, I'll just show you the data set that I got. So this is my raw data set, and if you actually want this data set, just go over to your Kaggle and type in IPL ball by ball data set from 2009 to 2025, and it's gonna revert you back with this data file. So just download this data set, post it over your raw folder, and you'll be good to go. Now I'm gonna go down and I'll explain you what exactly is this ensure dir function. So this function is simple. Ensure dir, it creates a folder even if it doesn't exist. And you can also see that we have exist OK as true. So it means that if it already exists, it won't need to throw an error. And then you go down to your safe diff function over here. So this is a safety function to avoid division errors. So sometimes we divide by overs bowled, and at the very start of an innings, overs bowled can be 0. So safe diff means that it would return NaN instead of crashing when the denominator is 0. So it keeps the pipeline stable. That's why we use this function, and I have described how this function works over here. Now I'll go down to my has header function. So this function, it tries to detect if the CSV contains headers, and it can read only the first row, and if the first cell contains the word match, it assumes headers exist, and if not, it checks whether the first value looks numeric because match IDs are numbers, and a numeric first cell usually means no headers. Then you go down to your course numeric. Now what is this function? So this function, it forces certain columns to be numeric. So in real data sets, blanks happen. So we convert to numbers safely, and if anything fails, we replace it with 0. So that's the benefit of having this function. Now we go down to our parse ball component. So this function, it solves a key cricket data problem. The ball is stored like 5.2, meaning 5 overs and second ball. But we also get 0.7 because wides and no balls create extra delivery. So this function, it splits the ball float into over raw. So as you can see, it splits the ball float into two parts. You have your over raw and you have your ball in over raw. So over raw is basically the over number, and ball in over raw is basically which delivery counts inside that over, including extra deliveries. So we use this mainly for correct sorting. Now I have also described the logic for here. So I will share you the code in the description so you can go through it, refer it according to your own way, and you'll be good to go. Now I'll go down to my load data. So what does this function do? Now we load the data set. Step 1, if the CSV has headers, we load it normally. If it does not, then we load it with header is equal to none and apply for our default calls 22, right? Now then we do a safety check. We confirm that we at least have these columns. We have match ID, innings, ball, run off bats and extras. Then we convert these key columns to numeric. And after that, we create a new column that is total runs is equal to runs off bat plus extras. And that becomes the total contribution to the scorecard for each delivery. Now two cricket specific things happen. First, wickets. So if wicket type is not empty, we set is wicket is equal to 1, right? And I have also mentioned that in the comments over here. And second, our cases we have legal delivery. So a T20 innings is 120 legal balls, and you have wides and no balls. They do not count as legal delivery. So we create is legal. So if our wides are 0 and our no balls are 0, it's a legal delivery. And otherwise, it's an extra delivery that adds runs but doesn't reduce the balls remaining. So this is the difference between a beginner code and a real mass state analytics. So I hope you understand why do we have this is legal function over here. Now you go down and we will see that we prepare something like parse ball components over here. So what exactly is parse ball component? So we prepare sorting columns using this parse ball components, and we sort by match, innings, over and ball and over. So this ensures that our cumulative sums, it happens in the right chronological order. And then I'll go down to my mass state, and this is the mass state at the ball level, and I will just highlight the start of build mass state ball over here. And now basically what we are going to do here is we build mass state for predicting chases. So we focus on innings 2 because the question is, given the situation right now, runs needed, balls left, wickets left, what is the probability the chasing team wins? So that is why we go for that. And now since we are focusing on innings 2, I'll highlight this innings 1 total. So first we calculate the innings 1 totals per match, and that gives innings 1 totals. And then for innings 2, we merge that into a chase data frame, and then we compute target is equal to chase innings 1 dot run plus 1. Then we go down and we compute our current score, the wickets lost, the legals ball that were bowled, and third one is critical that I'll let you know. So now we compute three most important cumulative stats. So first you have current score, and what exactly is current score? It's a cumulative sum of total runs, right? And then you have wickets lost, which is a cumulative sum of the wicket events, and then you have legal balls bowled, which is a cumulative sum of is legal. And the third one is critical because it ensures wides and no balls don't incorrectly consume balls. Now you go on to your balls remaining, runs remaining and wickets remaining. So now what we are doing is we convert those into the mass state features. So you have ball remaining, that is 120 minus the legal balls that were bowled, and then you have the runs remaining, that is the target minus the current score, and at last we have the wickets remaining, that is 10 minus the wickets lost. Now these three features alone already describe the mass state, as you can see that. So now I will just highlight my whole block CRR and RRR, and using CRR and RRR you actually calculate the run rate. So overs bowled equals the legal balls bowled divided by 6, and CRR is the current score divided by overs bowled, and overs remaining equal balls remaining divided by 6. On the other hand, RRR is runs remaining divided by 6 by overs remaining, and we use safe division, so early overs they don't crash the code. Now next, if you go down, you see a momentum. Now I will just highlight the momentum block over here. So what is happening here? Now momentum, we create a row ID that can be merged later safely, and then we take only the legal deliveries, and on legal deliveries we calculate rolling sums. So we have runs in last 12 legal balls, and you also have wickets in the last 12 legal balls, and then we merge these values back to the full data set and forward fill them. So even wide, no bowl, these rows get the latest momentum snapshot, and that gives us the last 12 runs and the last 12 wickets. So since you have an idea about that, as you can see, you have the last 12 runs and the last 12 wickets, and I have just grouped it with the match ID and the last 12 wickets over here. Now you go on to your extra features, which is the pressure plus the required boundaries. So these are the two extra analytic features, and I'll just explain it what exactly is. So pressure is RRR minus CRR. So if this is rising, the chase is getting harder, and required boundaries is runs remaining divided by 4. So it's not perfect cricket logic, but it gives a quick measure of the aggression that is required. Now you go down to your chase win function over here. So I'll just highlight the chase win block so you have a good idea of where we are right now over here. So what is happening over here? After all of this, we create the label, the answer our model will learn. So for each match, we check if the maximum chase score is greater than or equal to the target. And if yes, then the chase win is 1. And if not, then the chase win is 0. And every ball straight row in that match, it inherits that label. Now, after that, cut off after the chase has finished. So one more realistic step, once the chase has been achieved, the match ends, right? So we find the first row, that is the runs remaining, and it becomes 0. So, and we can remove anything after that. So this avoids the weird post-win rows in the data set. Now we'll go down to our output columns over here. So finally, we select only the important columns for the final data set, and this helps us in keeping the output clean, model ready, and easy to explain, right? Now, after that, we are done with the mass state at the ball level. Now, we'll deep dive into the mass state over level. Now, after that, we will create an over level data set. We define the over numbers using the legal balls that were bold, and every 6 legal balls equals 1 over. Then we take the last snapshot in each over. So at over 5, we stored the final state after the 6th legal ball of that over, and this creates the mass state over.csv. Now, after that, since you have an idea about the mass state at the over level, we go down to our plots. Now, I will highlight my plots function over here, right? So what does this exactly do? Finally, after all of the code that we have written, we run the pipeline and we ensure that the output folders, they exist. So now we create sanity-check plots. The idea is simple. If our mass state makes sense, then win rate should behave logically. For example, more runs remaining should reduce the win rate. More wickets remaining should increase the win rate. Higher required run rate should reduce the win rate, and higher pressure should reduce the run rate, right? So that's the only logic that we have used over here, and you can see we have plot win rate by bins, you have your runs remaining, you have your wickets remaining, you have your RRR, and you have your pressure. Now, after all of this, you go down to our main function. So this is where we run the pipeline. So here what we are doing is, first we load the data set, we build the ball level states, we build the over level states, save the both CSV, and then we generate the plots. And at the end, we print previews so that we can visually confirm output looks right. Now you understand what the code is doing, and this is where I paste the anti-gravity prompt as I did earlier. So this prompt, it basically tells anti-gravity what the input is and what outputs to create and what safely rules to follow, like not deleting files. So after you're done with all of these codes, you can just go on to your terminal and you can enter this command at Python EP2. Just name your Python file that you have created. For my case, it's EP2 build match state.py and see if our script runs. So as you can see, you have your perfect data set now. You have your ball level preview and you have your over level preview. And we will be using this data set in the further set of videos. For now, that's episode 2. We have created the data set that a win predictor can actually learn from. And in episode 3, we will train the first baseline model and turn these mass states into probabilities. So subscribe to the NIIT YouTube channel, and we are building this end to end. Thank you so much.